Hi everyone! Today we're going to be talking about absolute value functions. Our objective for today is that students will be able to graph absolute value equations and inequalities using a table of values. Let's get started. So back in chapter 1 we talked about absolute value equations and inequalities and we learned how to solve them. Today we're going to be talking about the absolute value function and learning how to graph it. So first of all, the absolute value function can be written as f of x equals the absolute value of x. All right, that is our absolute value function. Now, if we want to graph it, what we can do is we can create a table of values to help us graph it. So that's what we're going to do here. We're going to graph our absolute value parent function using a table of values. So what we would do is we would substitute in these values for x into our function. So if we were to substitute -3 in for x into here, the absolute value of -3 would give us +3. So that's what we would write as our output. Our input is our x, our output is the absolute value of x. So the absolute value of -2 would give you +2. Absolute value of -1 gives you +1. Absolute value of 0 is 0. Absolute value of 1 is 1. 2 is 2. 3 is 3. Now that we have our points, let's graph them on our graph. So starting with -3, 3 would be right here. -2, 2. -1, 1. 0, 0. 1, 1. 2, 2. And 3, 3. All right. Now we want to connect our dots with a line. So we get my line. There's the first one. Let's see. Let's get this to be more of a line. Get rid of that 3D. There we go. All right, and then we use a ruler. All right, always use a ruler to draw your lines, connect the dots. Now be sure to draw the arrows on the end because we want to remember that it's going on forever in both directions. And there is the graph of an absolute value function. All right, so I want to emphasize that the graph always looks like a V, okay? And we call the turning point the vertex. All right, so 0, 0 would be our vertex or our turning point. Now the domain of this graph, we want to think x-axis left to right. This arrow tells us it's going going up and to the left forever. This arrow tells us up and to the right forever. So therefore, left to right, our domain, it's going on forever in both directions. So the domain of the absolute value function would be from -infinity to +infinity. And then the range, we want to think bottom to top, y-axis. So the bottom of our graph would be right here. It doesn't go on forever down, but it starts at 0, 0. And then we know it's going to go up forever because of these two arrows. So it starts at 0 and goes up forever. Therefore, we would write the range as 0, from 0, including 0, so we use a bracket, to infinity. All right, so this is the parent function of the absolute value function. Now, they won't always be as simple as f of x equals the absolute value of x. So therefore, we need to know how to graph all different kinds of absolute value functions. And in order to graph them by using a table, these are the steps we need to follow. So to create a table of values, it's best to place the vertex in the middle of your table, then include values on both sides. So the x values that are less than that value and x values that are greater. So the first thing we want to do is find the x value of the vertex. And how we do this is we set the expression that's inside the absolute value bars equal to 0 and solve. Then we want to place this value, this x value, in the middle row of your table and then choose a few numbers less than it and a few numbers greater than it and complete the table, complete the x value side of your table. Then, to complete the table, what we want to do is plug those x values into our original function and get our y values as well. Then, plot all the points, connect your dots, and graph your absolute value function. Let's see some examples of this. All right, so example number 1, we want to graph this absolute value equation, and we want to give the domain and range once we graph it. All right, so starting with number 1, f of x equals absolute value of x minus 4. The first thing we want to do is find the x value of the vertex. So what we're going to do is we're going to take what's inside our absolute value expression. So that would be, oops, I wanted my highlighter. So that would be x minus 4. All right, so we want to take x minus 4 and set that equal to 0 in order to find the x value of our vertex. So add 4 to both sides. These will cancel out. X equals 4. Now, x equals 4 is the x value of our vertex, so we want to put that value in the middle of our table, in the middle row. And then we want to choose 3 numbers smaller and 3 numbers bigger than 4. So 3 numbers smaller than 4 would be 3, 2, and 1. 3 numbers bigger would be 5, 6, and 7. Now we want to take each of these x values and plug it into our function in order to get the f of x, or the output, or in this case the y of our ordered pairs. So if we first plug in 1, we get f of 1 equals the absolute value of 1 minus 4. This gives us the absolute value of negative 3, which is going to give us positive 3. So when x is 1, f of x is 3. Now, f of 2. We're plugging in 2 into our function. We get the absolute value of negative 2, which is just going to give us positive 2. So when x is 2, f of x is 2. F of 3. Plug 3 into our function. It's going to give us the absolute value of negative 1, which gives us positive 1. Now f of 4. Going to give us the absolute value of 4 minus 4, which gives us the absolute value of 0, which is 0. So we're just completing our table. All right, now I need some more space here. So we want to keep going. Now we want to plug in 5. So f of 5, absolute value, plugging 5 in for x. That's going to give us absolute value of 1, which is 1. And I'm sorry if you can hear my dog snoring in the background. She's sleeping right here next to me, and she won't stop snoring. F of 6, we're plugging 6 in. 6 minus 4. Absolute value of 2 is going to give us positive 2. And last but not least, f of 7. Absolute value of 7 minus 4. So that's going to give us 3. Alright, so we plugged each of our x values into our function, got our f of x values. Now we have all of our ordered pairs. So I'm going to zoom back in so we can graph this a little more easily. So now we want to take all these and graph them. So these are our ordered pairs, 1, 3, 2, 2, 3, 1, 4, 0, 5, 1, 6, 2, and 7, 3. So we want to plot all these points. So starting with 1, 3, that's going to give us that point right there. And let me zoom in so it's even easier to graph here. Then 2, 2, that point right there, 3, 1, 4, 0, 5, 1, 6, 2, and 7, 3. Alright, and it looks like a V, so we know we did it right. And now I'm going to draw my line here. And then another line on the other side, connect all of our dots. You guys have to use a ruler because we want straight lines here. Alright, and there's the graph of our absolute value function. Alright, now we want to identify the domain and the range. So the domain of this goes to the left forever and the right forever. So the domain would be all real numbers. And then the range, we look bottom to top, y-axis. The graph isn't down here. The graph starts at y equals 0, and then we know it goes up forever. So our range would be from 0 to positive infinity. And we're including 0 because there's a closed dot when y equals 0. So we use a bracket. And we are done. All right, number 3. So we've got f of x equals the absolute value of x plus 5. So first thing we want to do is find the x value of our vertex by setting what's inside the absolute value bars equal to 0. So we just have an x inside the absolute value bars. We take it out of the absolute value bars, drop those absolute value bars, and set it equal to 0. Therefore, the x value of our vertex is just 0. And we put that in the middle row of our table. Now we want to pick 3 values smaller than 0 and 3 values bigger than 0. So three numbers smaller than 0, let's go with -1, -2, and -3. 3 numbers greater than 0, 1, 2, and 3. Now what we want to do is complete our chart. So we want to plug in our x values and get our output, get our f of x, or our y coordinates. So if we plug -3 in, so f of -3 is going to give us the absolute value of -3 plus 5, which gives us absolute value of -3 is +3 plus 5 equals 8. So we want to plug in 8 over here. Then f of -2, plug -2 in. Absolute value of -2 plus 5. 2 plus 5 gives us 7. So when x is -2, f of x is 7. F of -3, or not -3, we already did -3. -1, absolute value of -1 plus 5. 1 plus 5 is going to give us 6. All right, then f of 0, if we plug 0 in, we get 0 plus 5, or 5. Then if we plug 1 in, f of 1, absolute value of 1 plus 5. 1 plus 5 gives us 6. F of 2. So yes, lots of work involved in these. Gives us 7. And then last but not least, just need a little more space here. F of 3. Absolute value of 3 plus 5 equals 8. So then we get an 8 over here. All right, now we've completed our table. So I'm going to zoom in so it's a little bit easier for us to graph. All right, now what we want to do is plot our points. So first up, -3, 8. So go to the left 3 and up 8. There's our first point. -2, 7. Second point. -1, 6. And let's see, 0, 5. Then we want to go 1, 6, 2, 7, and 3, 8. So we plotted all our points. Now we want to connect them with a line. And we know that it's going to look like a V. So our goal is to make sure that our graph looks like a V. And we want to be sure to draw those arrows on both ends so that we remember that it goes on forever in both directions. And we just graphed the absolute value of x plus 5. All right, now domain of this graph, of this absolute value graph is that it's going to be from -infinity to +infinity because the arrows tells us it goes left and right forever. And then range, we want to look at bottom to top, y-axis. Okay, so graph's not included down here. It starts right here at y equals 5, and then it goes up forever. So our range is going to be including 5 from 5 to infinity. All right, and we're done with number 3. If you have any questions on this, please raise your hand, call me over. Otherwise, let's move on. All right, so I want you guys to try number 5 on your own. All right, follow the steps to graphing absolute value equations by a table, or functions by using a table. When you come back, I'll have the answer written on your screen, and we will go through it together. All right, so go ahead and pause your video now and give this one a try. All right, so your graph of negative absolute value of x plus 1 should look something like this. So the first thing you should have done was first find the x value of your vertex by taking what's inside the absolute value bars, x plus 1, and setting it equal to 0. We get that the x value of our vertex is -1, so we place that in the middle row of our table. Then we want 3 numbers smaller than -1 and 3 numbers bigger. We take all these x values and plug them into our function, and that's what all of this work is over here, taking each x value, plugging it in, getting your f of x value, and we complete our table. Once we have all of our ordered pairs, we plot them on our graph, connect it with a ruler, make sure we put arrows on both ends so we know they're going forever in both directions, and we have our graph. Something I want you to notice is that if there's ever a negative sign outside the absolute value bars, it's going to be a V that's pointed down, all right? We're reflecting it across the x-axis. It's going to be a negative absolute value graph. So that means our V is going to be pointing down instead of pointing up. Now, the domain is still all real numbers because we know it goes to the left and the right forever because of these two arrows. And then our range tells us it's going down forever, but it stops at y equals 0. So our range is from negative infinity up until 0. And we're including 0 because there's a closed dot here at y equals 0. All right, so number 7 is a little bit different than the ones we've gone over so far because now I'm throwing a piecewise absolute value function at you. All right, so we've got a piecewise function, and a piece of that piecewise function is an absolute value function. So how do we begin? All right, first thing we want to do is write 2 tables for each of our piecewise functions. We've got our table that represents the first piece when for the function negative 2x plus 1, and then we've got a second table for the second part of our piecewise absolute value of x minus 3. All right, so there's our 2 tables. Now, how do we fill them in? It's a little bit different. So we don't just take what's inside the absolute value bars and set them equal to 0. All right, what we want to do is look at our domain here to tell us what numbers are going to go in the x part of our table. So for this top part, we know that x has to be less than 4. So the x values we want to choose are less than 4. All right, and we actually want to include 4 because we want to know where we're going to put that open circle. So we say 4, 3, 2, 1, 0, negative 1. All values less than 4, all right? And including 4 because we want to know where that open circle goes. Then the second piece of our piecewise is when x is greater than or equal to 4. So we want numbers equal to 4 and greater. So 4, 5, 6, 7. Those are the x values we choose for this function, all right? Now we just want to complete our tables, so we plug our x values into our functions and get our y. So for the first one, let's complete our negative 2x plus 1 table. So if we plug in negative 1, we're going to get positive 2 plus 1, or 3. If we plug in 0, we get 0 plus 1, which is 1. If we plug in 1, we get negative 2 times 1 plus 1. That's going to give us negative 2 plus 1, or negative 1. And then plugging in 2, we get negative 4 plus 1, which is going to give us negative 3. All right, and I'm going to need a little more space here, so let me zoom out. All right, and then we're plugging in 3, so negative 2 times 3 plus 1, negative 6 plus 1, gives us negative 5. And then last but not least, 2 times 4 plus 1, negative 8 plus 1, negative 7. All right, so we've got points for our first table. Now we want to plug in points for our second table for the second piece of our piecewise. We've got absolute value of x minus 3. So let's plug in a 4. All right, if we plug 4 in, we get absolute value of 4 minus 3. It's going to give us the absolute value of 1, which equals 1. Then we want to plug 5 in. That's going to give us 2. If we plug 6 in, that gives us 3. Plug 7 in. That's going to give us 4. All right. Now we want to take our points and we want to plot them on our graph. So we've got points from this table and points from this table. So let's start with the left side, all right, because we know our domain is going to change at x equals 4. So we know at this point right here, it's going to change, right? Let me see if I can make that a little bit more accurate here. I know our graph is a little small, and that's okay. So x equals 4. All right, that highlights it a little better. So we want to plot all of those points. So let's start with negative 1, 3. So we go to negative 1, up 3. Hold on. I need to be able to see this better. Let's zoom in. We don't need to see our work there. Okay. Negative 1, 3. There's our first point. 0, 1. Second point. 1, negative 1. Right there. 2, negative 3. 3, negative 5. And we know at 4, negative 7, it's going to be an open circle because where the domain changes, it's just less than 4. So we want an open circle right there. All right, so we've got our open circle, we've got our points, and we know we want this graph to the left of our domain change. So we draw our line using a ruler, connect all of our dots, make sure our arrow shows it's going on forever in that direction, and we're done with the right side. Now, that's the left side. Now we move on to the right side. So 4, 1, we know we're going to be at 4, 1, and it's going to be a closed circle because this side is greater than or equal to 4. Then 5, 2. So we go 5, 2. Or hold on, 4, 1. I put that at the wrong dot. 4, 1, 5, 2, 6, 3, and 7, 4. All right, so we plot our points, and that's what the right side of the absolute value graph is going to look like. And since it's a piecewise, we only want the part of the v that's to the right of x equals 4. All right, so it won't look like a v because we only want the right side. Now we can erase that highlighted part that shows us where the domain changed because we don't need it. If I can do this without deleting the rest of the graph. All right, because we don't need that highlighter or that line. Good enough. And we've got, not going to be able to zoom out here. Okay, so we've got our graph, the graph of our piecewise function here. Now we need to determine the domain and range. So domain, we want to look left to right, x-axis, and we see that it hits every value on the x-axis. The only open circle would be here, but there is a closed circle here, so we include 4 in our domain. So domain of this would be from negative infinity to positive infinity. Now range, we look bottom to top, y-axis. So starting at the bottom, it doesn't go on toward negative infinity forever. It starts right here at this point. And this would be at negative 3, 6, 7. So this is at y equals negative 7. And since it's an open circle here, we use a parenthesis because we're not including negative 7. So we say from negative 7, and we know it's going up forever. So we say from negative 7 to positive infinity is our range. All right, so that's kind of putting together two things we've learned so far in this chapter, piecewise functions and absolute value functions. A little bit more challenging, but I have faith in you guys that you can do this, all right? If you have any questions on anything, call me over so I can help you. Otherwise, let's move on. All right, so now we're moving on to graphing absolute value inequalities. So graphing absolute value inequalities is very similar to graphing absolute value functions, just with a couple slight differences. So it's going to be the same idea. We're going to start by creating a table of values, and it's the same process that the vertex should be in the middle row. So we set what's inside the absolute value bars equal to 0, find the x value of our vertex, and put it in the middle row. Then we want to complete our table of values just like we did for solving absolute value functions. All right, the difference comes when we go to graph it. So when we graph it, we want to be sure to use a dashed line if the inequality is just less than or greater than, and we want to use a solid line if it's less than or equal to or greater than or equal to. All right, so that's one of the differences. Is it a dashed line or is it a solid line? And then we also have to shade when we're dealing with inequalities, when we're graphing inequalities. So we want to shade above the line if it's greater than or equal to, or we want to shade below the line if it's less than or equal to. All right, let's go through a couple of examples so we can see this in action. All right, so number 1, we want to start the same way. We want to find the x value of our vertex. So we take what's inside the absolute value bars, x plus 1, and set it equal to 0. Subtract 1 from both sides, and we get that x equals negative 1. So negative 1 is going to go in the middle of our table of values, And then we want 3 numbers smaller, so -2, -3, and -4. 3 numbers bigger, 0, 1, and 2. Then we want to take each of these values and plug it into our function, all right? Now I'm just going to do this verbally. You can also do it in your head or use your calculator, all right? When they get a little bit more complicated, you need to show all your work. So for all the previous examples, I showed all of the work for every single problem. I know some of this is simple math that you can do in your head, okay? So yeah, I won't require you to show work for this part, like what I'm about to do. But if you get something wrong, can't give you partial credit if you don't show your work, all right? So if you're using mental math here, be sure you do it right. So we plug in -4. So -4 plus 1 is going to give you -3. Absolute value of -3 is +3. Plugging in -3 in for x, -3 plus 1 gives us -2. Absolute value of -2 is 2. Plugging in -2. -2 plus 1 gives you -1. Absolute value of -1 is 1. Plugging in -1. -1 plus 1 gives you 0. Absolute value of 0 is 0. Now if we plug 0 in, 0 plus 1 gives you 1. Absolute value of 1 is 1. Plugging in 1. 1 plus 1 gives you 2. Absolute value of 2 is 2. Plugging in 2. 2 plus 1 is 3. Absolute value of 3 is 3. All right, and we completed our table of values here. Now we want to plot all these points. So we start with -4, 3. So to the left 4, up 3, -3, 2, -2, 1, -1, 0, 0, 1, 1, 2, and 2, 3. All right, now because it's just a less than, so we look at our symbol, right, and our symbol is just less than. It's not less than or equal to. So because it's just less than, we want to use a dashed line. So when we draw our line, it needs to be dashed, all right? And you guys will use a ruler, so yours will be much straighter than this, all right? But when we can draw these lines, it's got to be dashed, all right? That was terrible. There we go. And then because it's less than means we want to shade below the graph, all right? So less than or equal to below the graph, greater than or greater than equal to above. So we want to shade the area that is below our absolute value graph. And we're done. So all of the shaded area is the solution to this absolute value inequality. All right, number 3. So same idea, we want to set what's inside of the absolute value bars equal to 0 to find the x value of our vertex. So we subtract 6, divide by 4, and we want to simplify, so x equals -3/2. -3/2 is going to go in the middle value of our table. Now, we want to pick 3 values smaller and 3 values bigger. And since this is a fraction, -3/2 is -1.5. We want to pick whole numbers because whole numbers are much easier to plug in. So let's pick -2, -3, and -4. Those are the next whole numbers, or next integers, not whole numbers because they're negative. So those are the next integers that are smaller than -3/2. Then we want 3 integers, or 3 numbers, bigger than -3/2, so that would be -1, 0, and 1. All right, then we want to plug each of these x values into our function. So when we plug -4 in, we get -4 times 4 gives us 16. -16 plus 6 gives us -10. Absolute value of -10 gives us +10. Plug in -3. 4 times -3 gives you -12, plus 6 gives you -6. Absolute value of -6 is 6. 4 times -2 gives you -8, plus 6 gives you -2. Absolute value of -2 is 2. All right, and then this next one I want to work out and show you because we're dealing with fractions here, and I know how much you guys love fractions. All right, so when we're plugging in absolute value of 4/1 times -3/2 plus 6, all right, we want to multiply straight across, so we get -12/2 plus 6, which is going to give us the absolute value of -6 plus 6, which gives you 0, all right? So 0 goes right there. Then when we're plugging in Negative 1. 4 times negative 1 gives us negative 4, plus 6 is 2. Absolute value of 2 is 2. Plug in 0. 0 times 4 is 0, plus 6 is 6. Absolute value of 6 is 6. Plug in 1. 1 times 4 gives you 4, plus 6 is 10. Absolute value of 10 is 10. All right, now we've got lots of points here, and we want to plot them all. Negative 4, 10 will go off the graph because the y-axis doesn't go that high, so we're not going to plot that point. Let's do negative 3, 6, so that's going to be right there. Negative 2, 2, right there. Negative 3 halves, 0, so that's going to be right there. Negative 1, 2 would be right there. 0, 6 would be right there, and 1, 10 would be off our graph, so we don't need to worry about it. All right, now because it's greater than, it's going to be a dash line because it's not greater than or equal to. So we do a dash line on this side, a dash line on this side, and you guys are using a ruler, so it's much better. And there's our absolute value graph. Now we want to shade above since it's greater than, so above would be this area right here. Anything up here would be above the V, okay? So I want you to think about it. If it's a V like this, above would be up here and below would be below the V, okay? So this is above because it's greater than, and there's your solution to this absolute value inequality, and you're done. All right, I want you guys to try number 5. It's the last problem we're going to do today. So go ahead and try to do number 5 on your own. When you come back, I'll have the answer written on your screen and we will go through it together. So go ahead and pause your video now. All right, so here's what number 5 should look like. So you should have started by finding the x value of your vertex, and you should have gotten 6 by setting what's inside the absolute value bars equal to 0. Place that in the middle row of our column and pick 3 numbers smaller and 3 numbers greater than 6. Then we want to take each of these values and plug it into our function. So we plug 3 in for x, multiply by 2, subtract 12, take the absolute value of that, then subtract 7. We get negative 1, and we want to do that for all of these values. Once we do that, we've got our points. We want to plot each of them on our graph, and we plot the ones that are on our graph. We know 9 negative 1's kind of go off, so we can't really fit that, but that's okay. Plot all the points we can, connect our dots with a solid line since it's greater than or equal to, so we know it's going to be a solid line. And then because it's greater than or equal to, not less than or equal to, we want to shade above. So above would be this section right here. All right, over here would be below, up here is above. And you're done. That is the solution to this absolute value inequality. All right, so if you have any questions on anything we learned today, please call me over so I can help you. Otherwise, look to the board to see what to do next, and I hope that you have a great day.